Today we're exploring a question that lies at the heart of both science and philosophy. Is there a deeper principle that underpins everything we see, from the energy that fuels our lives to the essence of consciousness itself? To answer this, we'll look closely at conservation laws, those bedrock principles that state certain quantities remain constant in nature, no matter how they transform. We'll examine how these laws interconnect through a triadic framework, revealing a deeper unity that echoes across systems large and small. We begin with the principle of correspondence, an ancient idea that suggests that patterns mirror each other across scales. From the vast structure of galaxies to the smallest particles, nature repeats in a harmonious way. As above, so below, as within, so without. This principle reminds us that at every level, from atoms to ecosystems, we see similar dynamics at work. But correspondence isn't just poetic. In modern physics, we see the same principle in conservation laws, each representing a triadic balance among three essential interdependent quantities. These triadic structures aren't isolated occurrences, they're interconnected, reflecting an underlying unity in how the universe organizes and conserves itself. So let's look at how each conservation law can be broken down into these triadic dependencies, seeing the larger structure that unites them. Conservation of energy is one of the most fundamental principles in physics. Energy can neither be created nor destroyed in a closed system, it only shifts between forms. Here, three key forms, kinetic energy, A, potential energy, B, and thermal energy, C, form a balanced triad. In a closed system, these forms coexist and constantly exchange. When a rock rolls down a hill, potential energy converts into kinetic, which may eventually transform into thermal energy due to friction. If any of these energy forms are absent, say, if thermal energy is not accounted for in a mechanical system, then the full picture of energy conservation cannot hold. Each form depends on the others to preserve total energy balance. This triadic relationship, kinetic, potential, and thermal, shows that energy conservation isn't simply about a static total. It's a constant dynamic shift between forms, where each one relies on the other two to maintain total balance. Next, momentum conservation applies in systems free of external forces, preserving the total momentum. But momentum has two facets, linear momentum, A, and angular momentum, B, both of which rely on mass, C, to maintain balance. Linear momentum and angular momentum support one another through mass, where any force that changes one type of momentum affects the other. For example, in a spinning figure skater, changing the distribution of mass affects angular momentum, which in turn influences the linear components of motion. If mass were absent, neither linear nor angular momentum would hold. They both rely on the presence of mass as the stabilizing factor, reinforcing the conservation of total momentum through mutual dependency. Linear momentum, angular momentum, and mass form a mutually reinforcing structure, each integral to the conservation of the whole. Charge conservation states that in a closed system, total electric charge remains constant. Here, positive charge, A, negative charge, B, and the net charge, C, form a triadic structure that maintains overall balance. Positive and negative charges balance to form a stable net charge. This conservation means charges can redistribute, but will always balance out to a constant net value. For example, when electrons move from one atom to another, the net charge in the system remains constant. If one polarity, positive or negative charge, were removed, the net charge remains conserved by adjusting the balance of the remaining charge. This mutual exclusivity keeps charge conservation intact even under transformation. This triadic structure of positive charge, negative charge, and net charge shows how charge conservation works as a balanced dynamic exchange within closed systems. Finally, we have angular momentum conservation, where three interconnected factors, angular velocity, A, moment of inertia, B, and angular momentum, C, maintain rotational stability. Moment of inertia links angular velocity and angular momentum, with each depending on the others. For example, a figure skater changing arm positions changes moment of inertia, which affects angular velocity, conserving total angular momentum. Without angular velocity or angular momentum, moment of inertia has no effect, illustrating how each factor depends on the presence of the other two for balance. These three, angular velocity, moment of inertia, and angular momentum, demonstrate conservation through continuous adjustment and dependency. As we've seen, each conservation law is more than just a statement about a static quantity. It's a balanced relationship among interdependent parts that form a triadic system. Energy, momentum, charge, mass energy, and angular momentum all demonstrate that nature preserves itself not through isolated rules, but through structures that balance transformation and interdependence. But what if these individual conservation laws are reflections of something greater? What if these triadic forms represent facets of one unified principle, a generalized law of conservation? Now that we've explored the intricate triads underlying each conservation law, we're ready to take things to the next level. In this part, we're going to see how the principle of correspondence unites these conservation laws, not as separate phenomena, but as expressions of one universal law, a generalized law of conservation. By the end of this section, we'll begin to see how conservation laws are interrelated patterns within a singular, coherent framework. And this framework, as we'll discover, holds implications that stretch beyond physics and into the very nature of consciousness itself. The principle of correspondence tells us that patterns echo across scales and realms. It's the insight that we see reflected in the structure of galaxies and atoms, the cyclical rhythms of ecosystems, and the symmetry in mathematics and physics. Correspondence suggests that conservation laws are not just isolated rules, but reflections of a singular, deeper reality. As above, so below, as within, so without. This principle, deeply rooted in ancient wisdom, tells us that patterns aren't isolated. They echo across reality, linking the small with the large, the seen with the unseen. So, when we see these triadic conservation structures in nature, they're not just scientific accidents. They're part of a broader pattern that runs through the fabric of reality itself. Now let's apply correspondence to each conservation law we discussed, showing how these triads are related and how they converge toward a generalized law of conservation. Let's begin with energy conservation. Recall that we looked at kinetic energy, A, potential energy, B, and thermal energy, C, as a triad. This isn't just a convenient way of categorizing forms of energy. It's a triadic relationship where each form can transform into the others while preserving the total amount of energy. In the principle of correspondence, energy transformation illustrates how coexistence and exchange manifest as a fundamental balance across different states. Kinetic, potential, and thermal energy coexist in a way that reflects a broader correspondence, that nature preserves balance through transformation. Energy's triadic balance mirrors transformation, persistence, and adaptation as essential qualities in nature. Just as kinetic, potential, and thermal energies transform while remaining in balance, transformation, persistence, and adaptation are universal themes echoed in countless systems, from ecosystems to psychological states. This triadic structure in energy conservation hints that the transformation we see in energy is mirrored at every level of existence, transforming but never losing its essence. With momentum conservation, we saw a triadic relationship where linear momentum, A, angular momentum, B, and mass, C, are interdependent. This isn't simply a mathematical necessity, it's a reflection of how motion, orientation, and structure correspond across systems. In correspondence, we find that momentum conservation echoes a universal principle of movement within stability. Linear and angular momentum, two forms of motion, are bound to mass, the structure that gives them substance. Momentum's balance reflects the triadic pattern of movement, stability, and orientation. Just as momentum relies on mass to remain conserved, movement relies on structure to maintain coherence, and orientation ensures that motion follows a meaningful path. This principle echoes beyond physical systems. In psychology, movement as motivation or action, structure as beliefs, and orientation as purpose balance to sustain the coherence of a person's life, a microcosmic reflection of momentum conservation. Charge conservation shows us yet another triadic pattern. Here, positive charge, A, negative charge, B, and the net charge, C, interact to conserve the total electric charge within any system. The principle of correspondence tells us that this triad reflects a universal balance between polarities that results in a net unity. Positive and negative charges are opposites, yet they're bound together in such a way that their total remains constant, a mirror of universal dualities that are balanced within a whole. Charge conservation reflects polarity, equilibrium, and unity. Positive and negative charges mirror any system of dualities, such as light and dark or yin and yang, creating a balanced unity in which the total essence is conserved. Through this lens, charge conservation isn't just about physical particles. It's about the broader balance of dualities, reflecting a cosmic tendency to balance opposing forces into a unified whole. Lastly, angular momentum conservation reveals a triadic relationship involving angular velocity, A, moment of inertia, B, and angular momentum, C. This triad shows how rotational motion relies on mass distribution and velocity to maintain balance. The principle of correspondence indicates that this balance of rotational movement mirrors broader ideas of motion around a center, where structure, moment of inertia, sustains movement, angular velocity, to preserve balance. Angular momentum's triadic balance mirrors cyclic motion, centrality, and balance. Just as planets orbit the Sun, centered motion in nature orbits around a stabilizing core, creating harmony through organized motion around a center. Angular momentum conservation reflects this dynamic balance found throughout the universe, where cycles are maintained by stable centers, from electrons around nuclei to planets around stars. When we step back and look at these triadic relationships, we start to see a unifying thread, a generalized law of conservation that suggests all conserved quantities are part of a dynamic balance, where transformation, balance, and interconnectedness operate together. This generalized law would state that all fundamental properties in closed systems are conserved through balanced, interdependent triads, preserving their integrity by transforming within a unified structure. This means that conservation isn't just about individual principles of energy or momentum. It's about a universal law of balance, where different aspects, whether kinetic energy, angular velocity, or charge, work together within a unified structure. But what if this law goes even further, applying not only to physical systems, but to consciousness itself? Could this generalized law reveal something fundamental about the nature of awareness, life, and existence? If conservation reflects an underlying unity of transformation and balance, then perhaps consciousness itself, with its capacity to observe, reflect, and integrate, follows a similar pattern. Ancient philosophies often liken consciousness to a mirror of the universe, a process that connects the inner and outer realities. Through the principle of correspondence, consciousness could be the very function that interprets, harmonizes, and conserves the universe within itself. We're not the first to consider this possibility. The idea that consciousness is part of a universal, conserved process appears across many ancient philosophies, from the Vedic tradition and Buddhist teachings to the wisdom of Hermeticism. These perspectives suggest that consciousness isn't merely a product of the brain, but is woven into the fabric of reality. Through the principle of correspondence, we can explore how consciousness might be an expression of the very same triadic balance that governs the physical world. Today we'll see consciousness not only as a participant in universal conservation, but as an integrative force, one that reflects, harmonizes, and preserves balance across dimensions of reality. In the Vedic tradition, consciousness is seen as a fundamental, unchanging reality, Brahman or Atman, the source from which all forms arise. It is the underlying consciousness that binds the universe together, a state that all beings share but may not always perceive. Here, consciousness isn't created or destroyed. It merely transforms in its expressions, existing in a continuous cycle of birth, life, and rebirth. The Vedic perspective aligns with our generalized law of conservation in this way. Consciousness, as Atman or Brahman, is conserved as an essence, taking form through interconnected states but remaining fundamentally invariant. In Vedic philosophy, consciousness manifests in three principal aspects: sat, or existence, is consciousness as pure being, the presence that persists regardless of form. Chit, or awareness, is the active, knowing aspect of consciousness. Ananda, or bliss, is the experience of unity and harmony within consciousness. These three, sat, chit, and ananda, create a balanced triad. Existence, awareness, and harmony uphold consciousness as a conserved essence, a continuous state across transformations. The Vedic tradition offers us this idea. Consciousness is a unified field, expressing itself through transformations yet maintaining an underlying constancy, much like the conservation laws in physics. In Buddhism, consciousness is understood as part of an interdependent chain known as pratitya samutpada, or dependent origination. Here, consciousness isn't an isolated entity, but a process arising from interrelated causes and conditions. Consciousness is conserved through karmic continuity, as actions and intentions shape future experiences. In Buddhism, the essence of consciousness is anatta, non-self. It's not a fixed entity, but a flow that conserves its continuity through causation. In the Buddhist view, consciousness can be seen as a balanced triad, comprising dukkha, or suffering, is the inevitable condition of existence due to attachment and impermanence. Anicca, or impermanence, is the constant transformation of consciousness. Anatta, or non-self, is the idea that consciousness lacks a permanent, unchanging identity. Dukkha, anicca, and anatta form a triadic structure, where consciousness persists as a sequence of transformations rather than as a static entity. Each element reflects an aspect of conservation through dependency and continuous change, aligning with the principle of correspondence. Consciousness here is conserved not as an essence, but as a process, an interplay of impermanence and causation. In Hermetic teachings attributed to the Egyptian sage Thoth, we find the maxim, as above, so below, as within, so without. Here, consciousness reflects the universe, suggesting that the inner world of mind and the outer world of nature mirror each other. Consciousness, in this view, is a conserved principle because it integrates and reflects every level of existence. In Hermeticism, consciousness embodies three primary principles: mentalism, that the universe itself is a mental construct; consciousness is the root of all; correspondence, that patterns repeat across levels, so that consciousness at one level reflects consciousness at another; vibration, that everything is in motion, suggesting that consciousness is dynamic, always shifting in state but maintaining an underlying continuity. This triadic model, mentalism, correspondence, and vibration, tells us that consciousness mirrors reality through continuous states of change, harmonizing itself with every part of existence. Consciousness is thus a conserved pattern, actively integrating and balancing information from the physical and mental realms. Now that we've seen these perspectives, we can return to our generalized law of conservation and apply it to consciousness. Our conservation triads in physics, energy, momentum, charge, and mass energy reflect a dynamic balance of interdependent parts. Consciousness, we suggest, operates through similar triads, sustaining its essence by balancing interconnected states. If we combine these ancient insights with our conservation triads, we start to see a new model of consciousness as a conserved, transformative process. Consciousness preserves itself through continuous relationships, echoing the unity we see in physical conservation laws. Here's how this translates in our model. Consciousness balances these aspects to sustain itself across experiences. It is both present, asat, perceiving, chit, and harmonizing, ananda. In Buddhism, these elements demonstrate that consciousness conserves itself as an ever-changing process, maintaining continuity without fixity. Hermetic teachings show consciousness as an active principle that corresponds to the universe itself, conserving its essence through continuous reflection and integration. These triads describe consciousness as a conserved pattern of interrelation and transformation. Consciousness isn't static, it's a dynamic unity that preserves itself by continuously harmonizing its aspects. This conservation model aligns perfectly with the physical laws we've examined, revealing consciousness as an integrated part of the universal order. Seeing consciousness as conserved has profound implications. It suggests that consciousness, like energy or momentum, is fundamental to the structure of reality. It's a principle that maintains balance by mirroring, integrating, and transforming. This conserved quality of consciousness aligns us with the universe itself. Just as energy and momentum uphold their constancy across systems, so consciousness reflects and conserves the essence of life across all forms. We see this in the Vedic idea of Brahman, the Buddhist view of karmic continuity, and the Hermetic insight that we mirror the cosmos. But what does this mean for us? It means that consciousness might be the key to understanding unity across all levels of reality, from the personal to the cosmic. Consciousness, by conserving its integrity through transformation, may be the bridge that harmonizes our inner experiences with the outer world. And it may be through understanding this conservation that we find our role as active participants in the universe's own balance. Now let's explore the implications of this model. We'll see how consciousness conservation could reshape our approach to science, philosophy, and even personal development. Imagine a world where we see ourselves as conscious participants in a conserved unity, an insight that might just hold the key to balance in every aspect of our lives. In Vedic and Hindu philosophy, Atman, the individual soul, is considered eternal and unchanging in its essence. Atman is viewed as a part of the universal consciousness, or Brahman, and is seen as undivided from this ultimate reality. Atman undergoes samsara, or the cycle of birth, death, and rebirth, until it achieves liberation, or moksha. Moksha is the realization of unity with Brahman, marking freedom from the cycles of change and dissolution. In this tradition, we can identify three key aspects related to the permanence of the soul. Atman, or the individual self, represents the personal, unchanging consciousness or soul within each being. Samsara, or the cycle of rebirth, is the ongoing cycle of change where the soul reincarnates, carrying forward experiences, karma, and tendencies across lives. Moksha, or liberation, is the transcendence of samsara, where the soul realizes its unity with Brahman and achieves a state of liberation. This triad, Atman, Samsara, and Moksha, creates a model in which the soul is conserved through change. The Atman remains constant across lifetimes, experiencing transformation but ultimately moving toward liberation. In essence, the soul here is not destroyed or diminished. Rather, it is balanced across individual identity, transformative cycles, and ultimate unity. In Buddhism, the concept of anatta, non-self, challenges the idea of a permanent, unchanging soul. Instead, Buddhism teaches that the self is a collection of changing experiences, or skandhas, aggregates, and that no permanent soul exists. However, consciousness is understood to be conserved through karma, the actions and intentions that shape future experiences. This karmic continuity persists across lives in a flow that sustains consciousness without a fixed soul. In the Buddhist framework, we can identify three elements that define the continuity of consciousness. Anatta, or non-self, begets the notion that there is no permanent, unchanging soul or self, emphasizing the transient nature of identity. Karma, or cause and effect, is the moral law that carries the results of actions and intentions, linking one existence to the next in a causal chain. Rebirth, or continuation of consciousness, implies that consciousness continues in a cycle shaped by karma, maintaining a continuity of experience across lives. Here, anatta, karma, and rebirth form a triadic structure in which the soul's permanence is redefined as a flowing cause and effect continuum. Rather than a static self, Buddhism proposes that the continuity of consciousness is conserved dynamically, relying on the interplay of these three principles. The soul here is a conserved pattern, sustained not through identity, but through causative continuity. In Hermeticism, attributed to Thoth, consciousness is described as a divine spark within each individual, a piece of the universal mind or divine consciousness. This spark is seen as eternal, reflecting the universal intelligence in miniature. Hermeticism views the soul as both individual and universal, moving through experiences of learning and growth to ultimately harmonize with the divine. This aligns with the Hermetic maxim, as above, so below, which expresses the soul's capacity to mirror the cosmos. In Hermetic thought, three central elements represent the permanence and unity of the soul. The divine spark of individual consciousness is the eternal part of each being that mirrors the universal mind. Correspondence, or the connection between micro and macro, establishes the principle that the soul reflects universal consciousness, maintaining a connection across levels of existence. Transmutation, or spiritual growth, is the soul's journey of purification and transformation, aiming to align the individual consciousness with the universal mind. In this triad, divine spark, correspondence, and transmutation, the soul's permanence is expressed as a mirror of the divine, conserved through continuous growth and spiritual alchemy. The soul is both a reflection of, and in harmony with, the universal consciousness, linking it to a cosmic balance. In ancient Egyptian spirituality, the concept of the soul was complex and multifaceted, encompassing multiple aspects that combine to create a lasting essence. The Egyptians believed in an immortal aspect of the soul that continued after death, guided through a complex journey to the afterlife. The Egyptians described three main aspects of the soul. Ba, or personality, is the unique individuality of a person, the qualities that made them who they were. Ka, or vital essence, is the life force, an animating spirit that continued after death. Ach, or transformed spirit, is the transfigured soul, a state achieved through the correct rituals, allowing the person to exist in the afterlife. In this triad, Ba, Ka, and Ach, the soul's permanence is maintained through a combination of personality, life force, and transformation. The soul transitions from earthly identity, Ba, to an enduring force, Ka, and ultimately to a divine, transformed essence, Ach, that persists in the afterlife. Here, conservation of the soul occurs through this layered process of transformation, where each stage sustains a different aspect of continuity. When we look across these four traditions, certain patterns emerge. Each tradition defines the permanence of the soul as a process of conservation through transformation, where the soul or consciousness endures by moving through states of identity, change, and unity. Here's how these align in a unified triadic model. Individual consciousness, self or spark. Each tradition posits a unique aspect of consciousness that is individual, whether it's Atman in the Vedas, the karmic stream in Buddhism, the divine spark in Hermeticism, or the Ba in Egyptian belief. Transformation process, change or evolution. All traditions incorporate a transformative journey, whether it's samsara, karma-driven rebirth, spiritual transmutation, or the journey from Ba to Ach. This process allows consciousness to shift and adapt, preserving continuity while changing form. Ultimate unity or liberation, the final state, whether moksha, nirvana, alignment with the universal mind, or transformation into Ach, reflects the soul's ultimate state of balance or harmony. This state is conserved as a form of unity or liberation, where individuality merges into a greater whole. Thus, we can see the permanence of the soul across these traditions as a triadic structure of individual identity, transformative journey, and ultimate unity. Bringing this together with our generalized conservation framework, we propose that consciousness, like physical quantities, conserves itself across individual identity, transformative processes, and ultimate unity. This triadic balance ensures that consciousness remains conserved, adapting through transformation yet maintaining a continuity of essence. Now, we'll explore how this unified triadic model of the soul relates directly to our physical conservation laws, completing the bridge between consciousness and the physical world. We've explored the triadic structures of conservation laws in physics, seen how these patterns echo across philosophies of consciousness, and considered how consciousness might itself follow a similar conservation principle. Now, we'll conclude by tying our model back to the physical universe, finding a unified understanding of conservation that spans from matter and energy to consciousness itself. Throughout our exploration, we've seen a recurring structure. In both physical and spiritual systems, conservation isn't about keeping things static. Instead, it's about a dynamic balance among interconnected quantities. Whether we're talking about energy transforming between kinetic potential and thermal forms, or consciousness moving through states of self, transformation, and unity, conservation involves ongoing relationships that maintain an overall whole. Why? The principle of correspondence showed us that the universe reflects itself at every level. The conservation laws in physics and the triadic structures of consciousness are not separate phenomena, but expressions of a deeper unity. This unity emerges through continuous transformation and interdependence. Let's look at how each of our conservation principles finds its counterpart in consciousness, creating a direct bridge from the physical to the mental and spiritual. Energy conservation and transformation teaches in the physical world, energy moves through kinetic, potential, and thermal states without ever being lost. Likewise, consciousness transforms across lives, identities, and experiences, maintaining an inner continuity. Consciousness mirrors energy in its adaptability and flow, transforming through states and expressions, but conserving an underlying essence. Momentum. Conservation and directionality teaches. In physics, momentum conservation provides stability in motion. It's why objects keep moving unless a force stops them. Similarly, consciousness has continuity. Across actions, intentions, and karmic cause and effect, we see a momentum in consciousness that preserves an intentionality or direction through transformations. Just as physical momentum depends on mass and velocity, consciousness depends on memory and continuity, creating a conserved direction through experience. Charge conservation and polarity teaches. Charge conservation holds the balance of positive and negative charges, much as consciousness integrates experiences of duality, joy and suffering, love and fear. Charge conservation reflects the polarities in consciousness, where opposites don't negate each other but create a dynamic, balanced whole. Angular momentum and cyclic continuity teaches. In physical systems, angular momentum conserves rotation, binding systems together in cycles. Consciousness reflects this cyclical nature in traditions like reincarnation or spiritual evolution, where experiences return and transform, cycling through growth and learning. Angular momentum cycles parallel consciousness's path of self-reflection and transformation, suggesting that both operate within systems of perpetual return and development. When we look at conservation laws through this lens, a remarkable picture comes into focus. Conservation is the expression of unity across all levels of existence. Physical and conscious realities are connected not by separate forces, but by a singular structure of balance that allows transformation within an integrated whole. In this view, consciousness itself might be an essential aspect of the universe's conserved fabric, existing as a relational field that aligns with the same principles governing energy, momentum, and mass. Consciousness, in our model, isn't isolated from the physical universe. It's woven into it, reflecting the same unity, continuity, and transformation we see in matter and energy. What does this mean for us? If consciousness is part of the universe's conserved essence, then perhaps our lives and our minds are not separate from physical reality, but expressions of it. This insight offers us a profound sense of belonging. We are participants in a conserved and interconnected universe. Our minds, actions, and intentions like energy and momentum have enduring impacts that ripple through the system, shaping reality even as reality shapes us. In understanding conservation as a universal principle, we glimpse our potential to harmonize with the universe, not as isolated beings, but as conscious participants in a vast, balanced whole. We're no longer mere observers. We're dynamic contributors to the universe's ongoing transformation and conservation. So, as we move forward, let's recognize that we are both energy and awareness, bound by the same laws that shape the stars and the atoms. Conservation, it turns out, is not just a physical constraint, it's an invitation to align with a balance that is ancient, universal, and beautifully whole. However, there is one more thing that I need to address, as there is a somewhat obvious omission from our exploration of the laws of conservation. We did not discuss mass-energy conservation as described in Einstein's famous equation, E=mc². Conservation of mass energy doesn't naturally fit a triadic model. Einstein's use of the constant CE for the speed of light, and using that to establish a conversion ratio, while incredibly effective for relating mass and energy in our observable context, doesn't provide a true third interdependent variable in the same way we see in the other triads. This equation lacks an active, fluctuating component to complete a triadic relationship. This suggests that c² has been fudged as a constant of proportionality. It's consistent within our local frame, allowing us to treat mass and energy as interdependent quantities, but it doesn't actively participate in dynamic balancing the way kinetic potential and thermal energy do in conservation of energy, for example. In our model, if conservation operates fundamentally through triadic relationships, then a truly robust theory of mass energy would also involve three dynamic interdependent components. Relying on a constant like c, rather than treating it as part of a triadic interaction that adjusts to different contexts, may indeed limit our ability to explain certain observations, and could be obscuring deeper relational mechanisms. In an effort to help offer some context on how to resolve this, I'd suggest that the rate of mass energy conversion and the speed of light are both dependent on a common underlying interaction, one that operates as a fundamental structure in space itself. This shared origin could imply that mass energy equivalence is not an isolated equation, but a localized expression of a more comprehensive, context-dependent relationship. If we accept this, then the speed of light, rather than being an absolute constant in all regions, might be a derived quantity that depends on other variables that we haven't yet fully identified. This perspective would have broad implications, potentially offering explanations for phenomena that we currently attribute to theoretical constructs like dark matter and dark energy. If the speed of light and mass energy conversion are determined by a shared underlying framework, then certain physical constants might not be universally fixed. Instead, they could vary in different spatial or energetic contexts. This would mean that values like c, or even g, the gravitational constant, are emergent properties based on local densities, fields, or spatial configurations, rather than being immutable universals. This approach would not only make mass-energy equivalence more compatible with a triadic conservation model, but could also help explain why some universal constants appear to work on average, but seem less precise in extreme conditions, such as near black holes or in high-energy cosmic events. If both mass energy and the speed of light are derived from a more fundamental triadic interaction, then space-time itself might be a relational construct, not a fixed stage on which matter and energy play out, but a responsive medium shaped by the interdependencies among mass, energy, and some underlying spatial factor. This relational view of spacetime could imply that mass-energy conversion occurs as a function of local spacetime properties. So, rather than being an absolute law, E equals mc squared might hold as an approximation under typical conditions within a particular gravitational field or spatial density, where the triadic balance remains relatively stable. In regions with different spatial configurations, such as dense galactic cores or vast cosmic voids, mass and energy relationships could adjust dynamically, producing variations in what we currently interpret as dark matter and energy effects. The current challenges with dark matter and dark energy stem largely from observed gravitational effects that don't match visible mass or standard energy assumptions. If mass-energy equivalence and the speed of light are indeed linked by a common underlying relationship, then these effects could be expressions of this fundamental relationship adjusting based on local context. Observed gravitational effects could result from variable gravitational influences that emerge from this shared triadic structure, rather than from invisible mass. In regions with higher densities, such as galaxies, the mass-energy relationship might shift, resulting in extra gravitational effects without additional measurable mass. Expansive effects in the universe's vacuum might stem from a dynamic balance in the underlying spatial structure, where mass-energy interactions create effects that appear as a repulsive force due to variations in the assumed constants across vast scales. Thus, the phenomena attributed to dark matter and dark energy could instead represent adaptive behaviors of mass, energy, and spacetime within a unified context-sensitive framework. If mass energy and the speed of light share a common foundation, this could suggest that universal conservation operates through triadic balance at every level of reality. Under this principle, mass and energy could conserve by continuously adapting within different spatial contexts, influenced by a third factor that modulates how mass and energy interrelate. This would mean that conservation itself is contextually adaptive, with constants like c and g shifting slightly to maintain balance as systems adapt to various gravitational or spatial conditions. This assumption could provide the missing link in our understanding of conservation, uniting physical constants under a flexible triadic model. If we were to consider what the third component in this relationship might be, space density or a field interaction could be promising directions. Such a factor would need to interact with both mass and energy to influence their interconversion, respond to local densities or spatial configurations to maintain an adaptive, constant relationship, allowing mass-energy conversion to hold universally but vary subtly in high-density or high-energy contexts. Account for gravity's influence in a way that is responsive rather than static, explaining variations in gravitational behavior without the need for invisible matter. This third factor could be related to what we perceive as gravitational constant effects, but with an adaptability that allows local context to determine its influence. If mass-energy equivalence and the speed of light share a common foundation rooted in a triadic balance, it suggests that our universe operates with an adaptive conservation model. Rather than fixed constants, we have relational variables that appear constant under stable conditions, but respond to local or situational factors. This model not only integrates conservation laws into a dynamic triadic structure, but also invites us to rethink spacetime and gravity as responsive rather than rigid frameworks. In this view, mass, energy, and the underlying structure of spacetime would conserve as part of a balanced system that flexibly adapts. This triadic understanding offers an open-ended framework, encouraging us to explore how interconnectedness governs everything from the speed of light to the gravitational constant, unifying our conservation principles in ways that align with both physical and conscious realities. This shift in perspective deepens our understanding of conservation, pushing us closer to a unified theory of nature's most fundamental relationships.